Conditional probability is really the probability that something happens given that we already know something. On the screen here you can see it's the probability of an event given that a previous event already happened. So the key here is going to be we're trying to calculate probabilities when we already know something else occurred. So in this case we'll look at, suppose you're dealt two cards. What's the conditional probability? Remember, conditional probability means I already know something else occurred, that the second card that you get is an ace, given that the first card was an ace. So the way we write that in probability is this. It says the probability that I get an ace given that I already got an ace. Now, normally we think of the probability of getting an ace. There are 4 aces out of 52 cards. We normally would say, hey, the probability I'm going to get an ace is 4 out of 52. The problem is I already know something occurred, so this is not the correct answer. I'm given that I already have an ace. So we have to remember there are no longer 4 aces in the deck because I already have one. So now the probability is there are 3 aces left. And there aren't 51 cards left in the deck because I have one of the aces. There are now only 51 cards in the deck. So this probability is 3 out of 51. There's 3 aces out of 51. The second question here says, what's the probability that I get a red card given that I already have a heart? Now, red cards. We know that typically there are 26 red cards out of 52 cards. Now, that would be the answer if I just asked what's the probability of a red card. But I already know something occurred. I am holding a heart in my hand. So I have to remember, a heart is a red card. There are not 26 red cards left. There are only 25 red cards left in the deck. And there are not 52 because I have one of the hearts in my hand. There are now 51. So conditional is knowing something already occurred and then calculating a probability. So this is going to occur a lot of times with two-way tables. Okay, a two-way table is a table that basically has rows and columns. You can read it two ways. That's why it's called a two-way table. And this problem that we'll be looking at, we have just a survey of how students get to school. We have 9th and 10th graders, how they get to school by bus, walk, car, or other methods. And 11th and 12th graders and how they get to school by bus, walk, car, or other methods. Now, typically the big idea here is you're going to want to try to find row and column totals when you see these two-way tables. So you're going to want to add up, all the bus people, all the walk people, cars, and other. Not only that, but you're going to want to add up all the 9th and 10th graders and all the 11th and 12th graders. And a good way to look at this is to see how many total students are over here. Let's see, 210 and 290, that's 500. How many total students show up on the bottom? And if you add all these together, you'll get 500. And that's a good way to check to make sure you didn't make a mistake. You should always get a total of 500, or you should always get an equal amount when you add down and when you add across. So question A, what's the probability that a student walked to school? Okay, well, it says a student, so this is all students we're referring to. And let's see, walkers. We had 88 walkers out of 500 total students. So the probability that if I pick a random student that they walked, it would be 88 out of 500. Okay, the second question says, what is the probability that a student surveyed was a 9th or 10th grader? So what I want to look at is, a lot of people get confused because there's the word or in there, but we have to remember this chart has 9 and 10th graders together. So the probability of a random student being a 9th or 10th grader, I'm going to take a look at the chart, and there are 200 9th and 10th graders out of 500 people. So there are 210 9th and 10th graders out of 500 total people. So it's 210 out of 500. Okay, other questions we could be asked. What's the probability that a student took either the bus or a car? So we're talking about bus or a car. Two different things here. So we've got to take a look at the bus people. Here's our bus people. And our car people. It says, what's the probability that if you pick a random student, they fall in that category? Well, there's 147 bus riders, and there are 254 car riders. Okay, that's a total of 401. If I put these together, there are 401 students out of a total of 500. This is my probability, 401 out of 500 students. Okay, another type of question. And here's where we're going to start to look at this conditional probability, given that I already know something. And what is the probability that a student rode the bus, given that they were a ninth or 10th grader? So I need to remember that we're going back to this idea, the probability that they rode the bus. Now I could do that, but we're given some information that they are a ninth or 10th grader. I'm going to just abbreviate real quick. So typically I'd say, hey, riding the bus, well, you know what? I see up here that there were 147 bus riders, but I have to be very, very careful now. Okay, I'm given ninth and 10th grade. It says you only want to look at these. That's what it's telling you. This second part is saying look at these. These are the only things you want to look at. So what I like to do is I actually like to, even if I'm doing this on paper, I like to get out a highlighter, or I'll circle with my pencil or pen. It says only look at ninth and 10th graders. It says I'm going to give you ninth and 10th graders. So I'm going to give you these people right here. Okay, only look at those. Now the question is saying, when you look at those, I'm going to give you only those people. Now let's talk about bus riders. So when I look at bus riders, out of these people, there are 106 bus riders out of a total of 210 people. So this is a different type of question when you start to deal with the two-way tables and the charts. It says there are 210 people that I was given to work with. I was given 210 ninth and 10th graders. Of those, what's the probability that they are bus riders? Well, there's 106 of those. 106 out of 210. That's the answer for that question right there. We could try another one. What is the probability that I get an 11th or 12th grader, given that, remember the symbol means given that, they rode in a car. Now remember, it's important when you see this given that, you only want to look at what you're given that. Okay, so I'm going to make this note again. Look at these. This is all I'm going to look at right here. Okay, look at these. The people that rode in the car. So I am going to, like I do usually, I'm going to highlight those. I'm only looking at people that rode in a car. So these are my people right here. All right, only look at those. Now answer the question. And the question is, if you're given these people only, what's the probability you get an 11th or 12th grader? Okay, well, out of these people, there are 184 11th and 12th graders, 184 of them, out of a total of 254. Okay, that would be my solution for the probability. 184 divided by 254. That's the probability. Okay, one more. It says, what is the probability that a surveyed student was a 9th or 10th grade, or they rode the bus? All right, now I've got another or. We have to just kind of keep that in mind. I know there's another or here, but we have to remember 9th and 10th graders are put together. It says, what's the probability that a student, okay, since we're using the word student and there is no given that in this problem, I have to remember we're looking at everybody. So we're talking about 500 people here, everybody. So out of 500 people, what's the probability that they were a 9th or 10th grader? Okay, I have 9th and 10th graders. Here they are, 210. Or they rode the bus, and here are my bus riders, 147. Now here's where we can make big mistakes. So make sure you catch this. This is very common for people to make a mistake here. This 210 was obtained by adding these numbers. Apologize there. Adding these numbers right here. Okay, this is how that 210 was obtained. Okay, important to see that. All right, the bus number was obtained by adding these numbers right here. Okay, and this is where we have a problem. Maybe you see what's going on. I've got some people that actually were double added here. If you look at this group of people, and I'm going to circle them here. If you look at these 106 people, they were double added. They were in this category when I added to get the 210. And they were in this category when I added the bus riders. We have a problem. Okay, this is a scenario where I have 210 people. I'm going to add 147, but I double added, so I need to take away the 106 because I can't count them twice. Okay, so I need to add those together. I got to do 210 plus 147, and then I need to take away the 106 because they were counted twice, and that is a total of 251 people. Okay, so really there's 251 people out of 500 that fall under this category. That's the probability that if I pick a random student, I get a 9th to 10th grader or someone who rode the bus.